Hi there, welcome back. As I mentioned in my last video, the next stage that I was going to follow and check was the power amp stage. The idea is to do everything from the phono input, which is the first stage where audio comes in, and the phono input is the easiest one to use for test purposes. So from the phono input all the way through to the speakers. Now this radio, this set, is a little bit more complex because this is stereo. I've done some other stereos, but the stereos do bring in a little bit more complexity because obviously the whole audio circuit is duplicated. If you recall what this top end looked like, it looked like quite a mess at one point with some of these big capacitors over here. These are electrolytics, non-polarized, and this thing is 100 microfarads, 4 volts, or 6 volts in some cases. The result after the change is this thing here. These are a Nichicon Muse, non-polarized, 100 microfarads, 35 volts. They fit a lot better, make everything a lot cleaner to work on. And the reason I did this, the reason I did this whole section here, and you'll see another section in a minute, is because I was literally working backwards. Now, even before getting to this stage, there is a stage with components that is after the secondaries of the transformers. If you follow a little bit of the way these things are done, the primary has the high voltages and is connected to the tubes and so on, and the secondaries really just go to the speakers. Sometimes with some sort of high frequency cut, Zobel networks, whatever, but they normally just have the speakers. Well, this thing has got something else on here. And that something else is these two. Remember I mentioned transformers, I thought they were chokes. They are in fact inductors. And these inductors are in line with some of those speakers that we have on the front of the radio. The reason is to actually do a little bit of crossover, separation between the mids, the bass, the mids and the highs. And again, two more of those big red capacitors were used on here. They are completely really buggered. So again, these Nichicon Muses were used. The whole of this circuitry here was checked. There is a rather unique way of connecting these, and if you recall in the first video I said maybe one channel was not being used. That is not the case. Let me show you. If you look closely here, what you'll see is this is a 9-pin tube socket. And the speaker connectors are the male part of that, but there's one pin missing, so you can actually connect it in two ways, either starting there or starting there. And then you have these indicators on here. That says M and R, that says M and L. Below this one it says Lichterkanal, so left channel, below, or rather rechter, that's the right channel, and below that one it says left channel. So you can actually connect it with that indicator pointing to the M in both cases if you want, and that gives you sort of the middle position for the speakers. The speakers are playing the role of mids or middle position. If you, basically the mono position, then if you connect it to R and L, you get the one speaker, or actually one pair of speakers, giving you sort of a right channel sound, and the other pair of speakers giving you the left channel sound. So you can actually get a stereo pair of speakers from this, the way you connect it on here for the internal speakers. Then there's also the external speakers, and they are here at the back. And the one says external speaker, the other one says left, and the other one says right, which again is a little bit confusing. But when we look at the schematic, it makes sense. This left speaker is actually connected just to the one channel, and it's sort of a bass channel. And then these two are sort of satellite tweeters that you would have on the left and right if you wanted to use the external speaker system. So that makes sense. Now, what didn't make sense for a while was when I looked at the schematic. It's pretty complex. Let me show you. If you look at the schematic and you get to the output stage, beyond the transformer, it's actually quite intimidating because each transformer connects to that socket, okay? But before the socket, it comes out of here, out of the transformer. The one side of the transformer is connected to ground. This is the secondary. Then it comes out here. That's your signal. Now that's your full band, full range signal, okay? There's actually a connection back to this circuit over here. And that makes sense. That's your feedback circuit that will go to the volume control section and the preamp tube. That sort of allows you to do some tonal adjustment. You'd have the bass switch here, and I think that's one of the other tonal controls. That gives you a selected feedback for different frequencies. So depending on what frequency you feed back there, that's the frequency. It's negative feedback, so that's the frequency that's going to reduce on the overall output. But let's forget about that for now. That's just negative feedback. What you have here now is your signal goes in two directions. It goes that way, and it goes through this capacitor. Now that's that little one that, or rather that's that big red one that I've replaced with the Nichicon Muse 100 microfarads. And if we forget about the top line for a second, if we follow this line here, it goes, first of all, it goes to that output, that satellite output. So that one goes to satellite output. It also goes down here, and it comes down here, and it goes to there. So it also goes to the tube socket, the output socket of the opposite channel. This one here does exactly the same thing. If you look at this one here, the signal comes out, feeds back, but goes through that capacitor, goes to the right satellite, and then it goes up to, again, that output socket of the opposite channel. So the way it works, it's actually interacting from one channel to the other. But when we look at the central speaker here, this is that central external speaker connection, it actually just goes back here through there and to the output. So that is an unimpeded output. It doesn't go through a capacitor. Now the capacitor will reduce bass frequencies. The smaller the capacitor, the less bass, the more treble you'll get. But this one is the full signal which goes to that output there. And there's your stereo switch. This is one of the stereo switches that will allow it to, if you activate it, to activate that option, that sort of separation option. Now, that is with regard to the external speakers. With regard to the internal speakers, what you have is the signal comes in here, it goes there, and it has two paths. One is a direct path to pin 3 of that socket, and the other one goes through that choke, which is that sort of transformer thingy I showed you, to pin 4 of this output socket. There is a switch here with a capacitor to ground, another one of those big guys, and this is the one that's on top of that transformer as well. I beg your pardon, this is the one on that on the chokes. These ones are the ones on the top of the set on the output transformer. But this again is the stereo switch, which will activate stereo conditioning, if you will, because when you connect this to ground, if you connect that point there to ground, what it does is it's going to filter some of the frequencies as well. So again, there's quite a complex system. You can actually go through this and find out what default positions these switches are in and what the effect will be. But the best thing to do, and this is what I've done, is follow every line and start painting it. And on the other screen, which is up here, you can't see it, this whole section has been painted and checked. I'll show you that in a minute, but this whole section has been painted and checked. And what it does is it gives you, when you do it like this, point to point, beep it out, measure resistance, measure capacitance if you have to. It gives you a better understanding of how the thing is built and where things are. Then you go back, which is what I've done. Follow these components, make sure they're all fine, make sure the switching works. Again, one component at a time, one connection at a time. It is pretty time consuming, but it does give you a very, very good understanding about how this thing works. And what I discovered when I was doing this, because the one thing I've said before, and I'll repeat that, every time you do a stage of restoration or repair, you test it. Now, what did I know? I knew that we had sound, right? I knew we had sound because we tested it. So when I did all this checking, I again checked to make sure that I had sound, because if you make a mistake on that stage, it's easy to go back and see what you've done wrong. If you repair the whole thing, restore the whole thing, you have no idea where you might have messed up, and that just makes it a hell of a lot more difficult to find the source of the problem. So when I did a check, I only had sound from one of these sockets. One of these sockets. And I thought, crap, I've messed something up. So I went back and I flipped these around. I thought maybe it was actually the speakers within the cabinet that had something wrong with it. And I found that whichever way around I connected the speakers, I only had sound from the one side. Then I thought maybe it's one of these tubes. If you remember, everything here is in duplicate. Left channel, right channel, left channel, right channel, left channel, right channel. So what I did was I decided to put a signal in here, and I fed a signal here through the signal generator, and I found that I was getting sound out of that speaker. If I fed it in here, this is with the set completely off and these tubes removed, I fed it here, I got sound from the other speaker. So I realized that at least in principle, nothing was wrong with the work I'd done there. So then I had to move back, and I did. And the problem I will show you within the set was actually from a previous repair. These things were made to last in those days, and when components failed, they failed, but the workmanship on these radios was incredible. So I figure it's when the guy changed some components, and I've actually found the component that's caused the problem. There was some bad soldering and there's a short there. That was all done when repairs were made on this set. When I did all those the checks, this whole section here is plugged on top of the, and part of this one, this is also part of the feedback circuit, which then feeds back to the bottom of the volume pot, which will add or subtract voltage at different frequencies depending on what feedback settings you have. All this, and a big part of this, is actually soldered onto the top of those output transformers, which is why it looks like a bit of a mess. There are a lot of components there, and you have to be very, very careful how you desolder things on there so you don't create any shorts, you don't break any components, you don't mess up any of the dial cords that are passing just above you. And so very careful, one step at a time, but that was done. And so everything has been done so far. It's been done this way to this point. This is what the top of those two output transformers looks like. You'll recognize some similarities between this channel and that channel. A lot of the components here, all the components here are identical. The difference on this side is we have these two big resistors on here. That is in the power supply line, including that one down there. That's part of the power supply circuit, which I checked previously. So these two sections have been cleaned out and redone. And here's another advantage of removing that front cover. It gives you access to this part of the radio, and it makes it a hell of a lot easier to remove components and solder components in there. The other thing I noticed, these haven't changed because these are actually very, very good capacitors. There's only two of them, but hey, they're good. They were checked. They've had some heat shrink put on and lead straightened and so on. The others are all new. Resistors are fine. I actually preferred to use this type of capacitor on here. Makes it easier to solder because you do have very little space. Heat shrinking as much as possible so you don't have any shorts. Be careful with lead dress. Try not to touch wires together because you could get oscillations if you do that. So try and follow the exact layout that they've given you originally. And I cleaned up this whole section. It's really the only way to get access to this part here, to clean it. So I've cleaned out the front. I could put the faceplate back on now, but I just want to leave it out because I'm still worried about that FM block, which I may have to open up to find out what's wrong with the FM. The friend of mine who owns this actually is a little bit nervous because of the FM. This radio belongs to his mother, and the lady listens to one channel, apparently. It's a classic channel radio channel, and he's really keen that this thing works on FM. That was really the whole purpose of having this thing restored. And what I've told him is a little suspense, never hurt anybody. I'm confident we'll get this sorted out. But I do have to do things in a certain order so we don't blow up more than we repair. Let me show you the underside. If you recall, I thought this might be HF when I did the first look, but it's not. This is actually where the audio, the phono input comes in. This for us is one of the most important inputs because it's the one we're going to use to connect any external sources like the MP3, or rather than the Bluetooth receiver. And this is really clever because I wondered why you had an ECC83, which is an audio preamp tube, dual triode tube, used for audio amplification, usually the first stage of audio amplification. I wondered why we had it right at this end, and it makes sense. This thing here is a balance controller, that balance regler or whatever it is, and they actually give you a little drawing as to what to do if you wanted to create a balance control, an external balance control. That's not of interest here, but it's there and it's been checked. And what this is the tube is right below there, so everything connects directly to the tube, and is amplified at this stage. So when the signal leaves this stage, which is these two wires here, which are screened, they've actually raised the level and they basically dropped the impedance of that line so that noise pickup becomes greatly reduced along the radio. If you carried this input signal across the set, you know, past HF lines and past power lines, you'd probably pick up quite a bit of noise. So this thing should be very, very quiet when we finally test the audio. But so that stage is complete. It goes in. One of the first places it gets to is the stereo button, because obviously you're playing with two channels coming in and you have to decide what to do with them. So they go to the back here, which is the stereo switch, and then it goes off into the switching between pickup input, or if you want it to be from your radio set, so one of the radio channels, and that's the switching that happens at the front here. So that's been all checked to there, and then I went back to the back end, so back to the output tubes, and this is what we find. These capacitors were all put in. Now, the strange thing about these capacitors, which I really am not impressed with, is they're a mix of capacitors. Most of them look like they've been burnt with solder, so they're old. They're not new capacitors. Somebody put in some old junk on here. The leads were extended. You got this yellow type one here. You got these MKP ones here. You got a Vima cap, which is a very good quality cap. But what it's doing there, I don't know. You got a couple of Rubicons on there. So everything was just slapped in here, and the result was somewhere at the back there by that red Vima, there's a short. And that's why the audio is coming all the way through, but it's not getting to the output tube. It actually goes through the final preamp tube, which is the second ECC83 or 12AX7, but it doesn't get to the output tube. So that's the next stage that I want to do there, and I'm convinced that we'll either find the short by desoldering the old components, and if we don't, it's easy enough to sort out, to find the source of the problem. I'm convinced it's some bad soldering going on here. So what I have changed here already are the bypass capacitors, the cathode bypass caps. These guys were in pretty bad shape. They are 100 microfarads. In that case, they use 15 volts. I'm using 50 volt ones, which is what I normally use, Nishikons. And these now are much smaller, so they're hidden under there. There's one there, and there's one hidden right under there. It gives us a bit more space to work. There's still quite a lot of work to do here, but this is where we're heading, towards a completed audio circuit, so we can test the audio stage, put some signals in, put them on the scope, see if we've got distortion. If we don't, clean out the tone controls, because they're still all jammed. Clean out the volume controls. The volume control is quite interesting. Let me show you. If you look at the volume control on this thing, it is quite interesting. It's actually, this is half of the volume control. This is for the one channel, the left or the right. They're the same. Now, the obvious things are, as I said, that you have the input coming in after the audio selection, so forget about that. The signal that comes in here is your audio signal. It goes through this capacitor, and then it's into the into the volume control and tone control proper. So your signal comes in here. If you follow it, there's a capacitor there, 680 picofarads. That's for high frequencies. You've got a pot here, which is a 16 mega ohm pot. This 16 mega ohm pot actually connects to a switch. This is one of those tonal switches. If this thing is not active, the sound goes through there and to the top of your volume pot. But what they do is they do some conditioning with this here before it goes to the volume pot, and that conditioning will probably be bass. Is it bass or treble? I'm not sure right now. One of those, bass or treble. I haven't done the section yet. And then you get into this and you've got all the switching going on here. Now these are some of those tone conditioner switches, you know, jazz, intimate, bass and solo. Depending on which ones you press, it's going to cut out or pass through certain parts of the frequency band. So more bass, less mid-range, more mid-range, whatever. And this is all done with that switching circuit. Then you get to the actual top of the volume control, and that would be the standard input to the volume control. The bottom would normally go to ground. This one doesn't, but it goes close to ground. I'll get to that in a second. And there's your wiper, and your wiper then goes to the preamp, which is half of that 12AX7 or ECC83. So far standard. Then you've got all these taps going off here. Now these taps are interesting because they are at fixed positions on the volume pot, which is a 1.3 mega ohm pot. Now let's say that at 100 kilo ohms there's a tapping, and that tapping comes out and there's a 68k resistor. Let's say that at 200 kilo ohms there's another tap, and that comes out and it goes through a resistor and a capacitor. And let's say that at 300 or 400 whatever kilo ohms there's that tap which comes through another resistor capacitor. Now what this is, it's to shape your tone at lower than maximum volumes. So if your volume is set to the maximum, so if the wiper's at the top, the effect of these guys is very small. But if your wiper is down here at listening levels, normal listening levels, you will get a varying degree of tonal control, usually by giving more bass. So it's a sort of old-fashioned loudness switch, as it were, but it's a variable one depending on what level of volume you have. Now this is very, very interesting and very, very difficult to reproduce. If this volume pot is buggered, then you just can't create this effect. You can simply get the signal to come in and connect this to the bottom and your wipers out. You can get your volume control, but you won't get that richness that these radios are so famous for at sort of room listening levels, lower volumes. These things work fantastically. I've never actually looked at a simulation of this, which would be quite interesting, to actually put this on Spice, one of the Spice simulators, and see what happens. But again, it'll depend on what level of volume control you've got. But here we go. That's what this is. That's why that volume pot, which I'll show you in a second, is so complex. You will have at the volume pot the top one, the bottom one, the wiper. So 1, 2, 3, 4, 5, 6 contacts for each half, because the other side, the other channel, has exactly the same thing. So yeah, a lot of attention went into these radios, which is another reason why I believe you've got to really apply yourself to these, because they deserve it. They are really well designed and unique, and getting this thing back to like it used to work before is just it's a satisfaction that's very difficult to explain. You've got to be there. Right, let me show you that volume pot. This is the volume control, and you'll see there are components connected everywhere. There seems to be 2 of everything, and there will be because it's the stereo system. But this is a stereo pot, one channel and the other channel, and then you've got all these components, resistors and capacitors, connected in here to make up that circuitry that you saw back there. This thing has 2 outputs, one for the left channel, one for the right channel, from the wiper, which goes to the respective triode in that ECC83. But from this whole scheme here, you've also got quite a few wires going off to those respective switches that I mentioned. You know, the tone control or tone preset switches, the bass and the intimate and the solo, whichever ones are in that schematic. I can't actually read them too well from here. There's solo and there's jazz. Yeah, so solo and jazz have effect on this. So switches have to go, wires have to go to those switches. So this is actually quite an interesting mess when you look at it. And it has to be done. I haven't done this yet. I think these caps are fine. They tend to be. This would be fine. I've got to check resistors. I've got to check the contacts. I've got to check the continuity. So there's still quite a bit of work to do. But I just wanted to show you these things. If this thing is messed, then you actually lose a lot of the richness in low volumes that this radio is giving you, or will give you, when it's working properly. Right, let me carry on then. And what you're seeing here is the result of quite a bit of checking and replacing and correcting, but this is the entire power amplifier section. Obviously the power supply is here as well. But what I said I was going to do, which is take the signal from the input, the Phono input, follow through, check and replace, all the way through the first triode, goes into this section here, the selector switch, which determines whether you're going to hear radio or the inputs. That's that switch over there. And then going through the tone, or part of the tone control here. This is the bass and the bass and volume. This then goes through to the first triode of the second preamp tube. You've got the feedback circuit over here, affecting the bass, or the bottom of that volume pot. Then over here we have a treble control. That there is the treble. It goes through there into the power output power tube, through the transformer, then obviously into the speaker system. Now this is identical for the other side, as you can see. Now the one thing that's missing here is, you'll notice that I have certain components that aren't painted in, like that one over there, that capacitor. That capacitor. There are quite a few coupling capacitors here, which I am waiting for because I ran out. These are all 10 nanofarads, and contrary to what was done here, I don't intend to pick up the first 10 nanofarad caps I can find. For that, I'd leave the ones in there for now, and that's exactly what I decided to do. I checked all connections and everything else. I actually checked values, and I checked whether they were leaking badly. They are not, but I'm going to change them anyway. But because I'm waiting for these components, I decided to go ahead, do the full check on the power amp so we can test it. What will happen when we change those capacitors is, all we can expect is a little bit more fidelity, better quality. But everything is working here, and it ran into a couple of snags. There was a shorted output on the one side, as I mentioned. That's been corrected. That was touching where it shouldn't. One of those, actually, this resistor here was touching ground. Just as well it wasn't that side of that capacitor, because that would have been a short to ground. But it was touching ground, so effectively here you're getting 0 volts or 0 signal. But anyway, that's all done, and I've put it up and it's working. But I'll show you that in the scope in a minute. What I wanted to explain here was this. What we have here is the Phono input, and as you can see, there's the left channel, right channel, and the center goes to ground. Perfectly normal. What we have here, which is an identical socket at the back, is something called a balance controller, and you have to be careful that you don't plug in your Phono into the wrong one. Just trying to figure out whether anything drastic would happen. Not really. Well, yeah, maybe you'd effectively be feeding the signal into there. It probably won't blow anything, but it's not a good idea. So I have to make sure at the end, because I'm going to use that input for a Bluetooth, I'm probably going to add a jack to the back, a stereo jack to the back, so there's no question as to where the Bluetooth receiver goes into. So that there's the balance. And then over here we got the tape deck. And the tape deck, what it does is it can operate as a input device and also as a taping device. So I've done all the checking. I'm not too bothered with its function because basically all it's going to be is another source, effectively. This is usually more for recording than playing back, but you could play back through there because it just, if you take that signal there, it goes through there, in there, and it's into the audio chain. And the same with the other channel. But it's been checked, it's fine. What else can I tell you about this? Well, not much. What I did do is I connected the speakers, or actually my tester box there, which has a dummy load inside, and also a connection to the speaker, and it's connected to the oscilloscope so we can follow the scope. I've connected that to here on both channels, so left and right. So we're getting the full output on the secondary. There's no speaker connected. This signal, this point here, goes to the load and speaker distribution box. So what we're seeing is the cleanest version of the output. And as far as the input is concerned, this thing uses one of those 5-pin DIN plugs. It's got a 5-pin DIN socket. You only use 3 really. And you do find them, you can find them. And I happen to have a piece lying around, just the socket and a piece of cable. And that's what I've connected. Let me show you. Here it is. It's a 5-pin male DIN plug. The extreme ones are the signals, and that top middle one is ground. And this thing had 5 wires coming out of it. I removed the ones that don't apply, and I've shorted the 2 signals. So I've got my signal generator going in here and connected to ground there, and that then plugs into the back of the radio in the gramophone input. And what we're going to see through here will be a 1 kilohertz signal, amplitude of 100 millivolts RMS for now. So let's set that up. I'll show you where the outputs are connected now. There's my input now. I have taken this ground connection from the antenna, in the antenna sockets. Got a little plug in there with a good ground point. The 2 grounds for the load and speaker connections are connected to here. This is where the respective speaker outputs are taken from. Be very, very careful because you do have high voltages over here. So you need to make sure that you don't connect it to the wrong one because you'll have some fireworks. And then that goes to the load box. And the load box is left speaker in here, right speaker in here. The 2 are connected to the respective channels of the scope. This switch allows me to go dummy, none, or speaker. If it's the same with the other one. If it's dummy, I can use 8 ohms or 4 ohms. So we leave it on 8 ohms for now. This is not the right impedance. Those speakers, when they're joined together, give you some really strange impedances because they're sort of in series parallel. Some of them are really parallel for certain frequencies, so you'd have like 4 ohms maybe, or even less. In some cases you have the capacitor and the choke in line, so that'll affect the impedance for different frequencies. So let's stick with 8 ohms and we'll take it from there. Okay, so let's put the volume up. You can obviously hear it, but to get rid of the noise, let's put that on dummy load and that on dummy load. Much more comfortable. So here are our 2 channels, and we immediately can detect some difference in the levels. If you see that, you've got the one channel slightly higher than the other. Now, that could be all sorts of things. It could be the volume pot, which I'm adjusting now, which is not pretty well balanced. There's some noise on there, so there's still a little bit of cleaning on the pots to do. There's also, let me see if that's not a problem. There is some noise. Let's see if it's not. Yep, it's the tone control. Now, if we bear in mind that I haven't done any real cleaning, this I'm changing the tone, I'm moving the treble. Now this is a 1 kilohertz signal. I'm moving the treble, and there's obviously a lot of capacitors here, or some capacitors that need changing. If I take that to the end, I'm probably overloading it a bit. But anyway, you see a little bit of artifacts here. That's obviously something we need to look into, but that'll come with the replacement of the capacitors, I'm sure. But basically, we've got our 2 channels working, and the difference is not significant. If I take this a little lower, let's give it a bit more volume. It's starting to distort over there. Now, if I leave it on here, remember this load is not exactly what the radio will see. This system will see the internal speakers, which are different load characteristics. But if we look at that, the levels are pretty good actually. 1.89 to 1.93 volts is what you're seeing over there. Now, I haven't cleaned speaker sockets, tube sockets. I've got a bit more cleaning on the pots to do, the tone controls. They are moving now. This is the bass I'm changing, which doesn't affect much. The treble obviously does affect it, and you see it jumps there. So there's obviously a bit of cleaning to do on this on the treble pot as well. It'll jump in. There's some dirt on that pot. Okay, we'll have to do a bit of work there, but I just wanted to show you we've got basically the power amp working, and it's working pretty well. Considering the component changes that still need to be done, and the cleaning will obviously be, the moving parts are the ones that are a big variable here. This might be, let me turn that off. There's a bit of distortion on that waveform. This could be, I'll have to check that. It's a bit strange. It's only on the lower half cycle. So it could be the tube, it could be the biasing of the tube. Again, I don't trust those capacitors too much, so I won't make a judgment till I've replaced them with ones that I do trust. But anyway, that's what we have so far. And this part is almost done and dusted, and it's almost time to go to the radio section. And the first one of that obviously will be the AM. Ha! I know. The FM is the big incognito, but I'll leave that till the end because that one needs inspiration. When you don't have anything, any signal at all, which is the case with the FM, it's actually better. This might sound strange. I get absolutely nothing when I select FM. If I got noise and couldn't tune in, if I got all sorts of stuff different to nothing, then I could have a serious problem. With nothing, I'm beginning to believe it may be a connection problem. There have been a couple of shorts that I've found here, like on that one channel, shorted to ground. Now, if the output from this, when it goes to the switching, if there's a short to ground, it just means that when I select FM, it is seeing 0 signal, no matter what this is sending it. So I'm quite confident that we'll find the problem. As I said to my friend, I've done this before. I've had this problem before. I've had some very serious problems with these, which took quite a while, but got them sorted as well. So I don't see why this one should be any different. All right, that's another phase done. And there's just one thing I want to show you still. And then we'll wrap up this video. I'm going to measure the voltage on the lamps, the AC voltage on the lamps, and I'm going to reach over to the one that's on top here, which is most easily accessible, and I'll just touch the chassis for ground. And what are we getting? We're getting, no, it's not working. 6.99. If I push it a bit more, hang on, come on. 7 volts, right. 7 volts, it's a bit high. So this should be 6.3. and it's a bit high, which means that because that 7 volts there is the same as the heater voltage on quite a few of these tubes, it means that the tube heaters are getting a little bit more voltage than they should. So what I'm going to do is I'm going to change that voltage selector switch at the back to 240 volts. At the moment it's on 220. I'm actually getting, at the moment, contrary to what my dim bulb tester meter says, because that's going a bit funny, I'm actually getting on the line 233 volts. That's my mains voltage. Now with 220, obviously this is about 5% high, which seems about right. So I'll change it to 240 and see what we get. Okay, I've flipped the voltage selector, the mains voltage selector, to 240 volts input, and let's see what we get on the heaters now. Let's let it settle. So it was at 7 volts, it's come down to 6.46. It may drop just a bit. Yep, that's more like it, 6.4. So it should be 6.3 or thereabouts, plus or minus a few percent. So this is pretty fine. I can't get it any lower because I don't have any other selector position other than 240. That's the highest selector I've got there. But I also have a slightly higher than normal mains voltage here where I am. So even if wherever this is used comes down to 230, 225, which is the more usual values, this will be fine. So that's another problem solved, and what we've done is we've basically extended the life of the tubes a little bit, which is always good. All right, that's it for now. I hope you enjoyed this episode, and hope you join me again for the next one. And if you like this stuff, please subscribe. See you soon.